Lesson 1. The internal structure of the Earth. The primitive Earth was undifferentiated, homogeneous mass of solid rock when it was formed around 4.5 gigayears ago. Iron catastrophe. It is the process of differentiation. It occurred when temperature of Earth went beyond the melting point of iron. There are three layers of Earth: the crust, mantle, and the core. What is crust? Crust is the outer layer of the Earth. It is very thin. It is 7 to 10 kilometers beneath the oceans and 25 to 70 kilometers beneath the continents. There are two types of crust: oceanic crust and continental crust. So what is oceanic crust? It is generally younger, thinner, and denser, and it is composed of silica and magnesium-based basalt rock, while continental crust is older, thicker, and less dense. It is composed of silica and aluminum-based granite rocks. Mantle. It is maximum thickness of about 2,885 km. And peridotite is the rocks that are formed within the mantle, which are olivine and pyroxene. The layer of the mantle are cooler upper mantle and hotter lower mantle. Cooler upper mantle is 480 to 900 degrees Celsius, while hotter lower mantle is 3,880 degrees Celsius. Next, core. There are two layers of core, the outer core and the inner core. Outer core is composed of solid iron alloy. It is 2,270 km, and inner core is made up of liquid iron alloy, and it is 1,216 km. There are two layers of the uppermost part of the Earth. First is the lithosphere, second is the atmosphere. So what is lithosphere? From the Latin lithos, meaning rock. It is composed of crust and the upper mantle. What is lithosphere? From the Latin lithos, meaning rock. It is composed of the crust and the upper mantle. And atmosphere consists of the hotter lower mantle, greater than 1,280 degrees Celsius. It is also plastic and can flow very slowly, 1 centimeter every year to 5 centimeter every year.
Lesson 2. Continental Drift Theory. In the early days, geologic phenomena such as earthquakes and volcanic explosions were thought to be caused by supernatural forces. It was thought that the planet was formed the way it is. This idea started to change radically in 1915 when Alfred Wegener, a German meteorologist, introduced the continental drift theory in his book, The Original of Continents and Oceans. He proposed that a long time ago in the geologic past, the continents formed a single landmass, when he called Pangaea, that broke into several continents and drifted to their current positions. He used observations and concepts from the fields of geography, geology, biology, and paleontology to support this hypothesis. The fit of the continental shorelines. Although it was previously pointed out by observers before him, Wegener viewed the apparent fit of the continents along their coastlines as pieces of a jigsaw puzzle, an indication that the continents were once joined together. For example, the coast of Africa fits well with the eastern coast of South America and the southeast coast of North America. Distribution of glacial sediments. Wegener plotted in the map the location of the sediments and rocks that were formed during the last glaciation of the late Paleozoic. He also analyzed the orientation of the striations or the scratches imprinted as glaciers moved along the surface of rocks. These sediments are present in southern parts of South America, Africa, India, Australia, and also Antarctica. With the exception of Antarctica, it is unlikely that these sediments formed if the continents were in their current locations. Moreover, the current orientation of the striations indicates that the glaciers moved from the ocean toward the land, an unlikely occurrence based on observation in present-day glaciers. This can only make sense if the continents are joined together, following the concept of Pangaea. Paleoclimate. If the southern part of Pangaea is located in the polar region, as indicated by the presence of glaciers, then it follows that the rest of the supercontinent extended to the equatorial region and to the northern hemisphere. As observed today, the equatorial region has a tropical climate characterized by conditions that favor lush vegetation such as abundant rainfall and warm temperature. There are rocks that were formed under a particular climate regime, including coal or accumulated plant remnants. However, coal deposits are found even in areas that presently do not have a tropical climate but are likely to have had, as these were located in the equatorial region during existence of Pangaea. This apparent shifting of climate belts indicates that the continents have been moving around over time.
Lesson 3. Seafloor spread. As presented by Alfred Wegener are compatible with the concept of Pangaea. But the theory was rejected by geologists because Wegener could not present a believable mechanism of explain of how Pangaea broke apart. The seafloor spreading theory were made by other geologists. One of these came from studying Earth's magnetic field. Basals contain a small amount of magnetic minerals such as magnetic and hematite. These minerals retain the magnetic signatures that reflect the magnetic field scenario during the time of their formation. Geologists have used the magnetometer to measure the magnetic field of rocks. If the magnetic field of the rocks are the same with the current magnetic field, it would register strong and or positive anomaly in the magnetometer. In contrast, if the magnetic field of the rocks is different from the current magnetic field, the magnetic field would be weak and a negative magnetic field anomaly would be recorded. If there were no movement of the poles or the continents, the magnetic field of the rocks in the whole planet would be consistent with the current magnetic field conditions. During the time that the paleomagnetism in the rocks are being studied, another group of scientists developed a method of determining the numerical age of rocks. They found out that the seafloor is youngest in area near the mid-oceanic ridge and become older as it goes farther away on the other side. Another evidence was strongly supports seafloor spreading was seen in the thickness and age of sediments that were directly overlaying the basals in the mid-oceanic ridges. The concept of the seafloor spreading suggests that sediments overlaying the older seafloor should be thicker and older compared to those overlaying newly formed seafloor.
Lesson 4. Plate tectonics. Plate tectonics unifies the concept of continental drift, seafloor spreading, magnetic field reversals, and other geological and geophysical discoveries. The remarkable feat of the continents, as contended by Wegener and others, was confirmed in 1965. Consists of several irregularly shaped pieces called tectonic plates. The major plates in the world are African plate, Antarctic plate, Eurasian plate, Indian plate, Australian plate, North American plate, Pacific plate, South American plate, Arabian plate, Caribbean plate, Caucasus plate, Juan de Fuca plate, Nazca plate, Philippine plate, and Scotia plate. There are three types of plate boundaries: divergent, convergent, and transform plate boundaries. A divergent boundary occurs when two tectonic plates move away from each other. Along these boundaries, lava comes out from the center of the ridge and eventually solidifies into basalt. This effectively produces new oceanic plates. The most prominent mid-ocean ridge, which is located in the Atlantic Ocean. It is called Mid-Atlantic Ridge. This is where the South American plate and North American plate diverge from the African plate and the Eurasian respectively. There are areas of rip zones, where continents begins to stretch, break apart, and widen through time. The common example of an active rip is the Eastern African system, where the eastern part of Africa is breaking apart from the rest of the continent.
A convergent boundary is where two plates move toward each other. When interacting plates are both oceanic, the denser plate sinks beneath the lighter one and heads back to the mantle. When one is oceanic and the other is continental, the oceanic plate sinks below the less dense continental plate. This process is called subduction. In contrast to divergent boundaries, plates are destroyed in convergent boundaries. Subduction results in the formation of a chain of volcanoes called volcanic arc on the edge of the overriding plate. It is particularly called an island arc if it is formed from the subduction of an oceanic plate beneath another oceanic plate, and continental volcanic arc if it is formed from the subduction of an oceanic plate beneath a continental plate. Subduction zones are marked topographically by a long, linear, deep portion of the ocean floor called a trench, and geologically by volcanic arc on the overriding plate. Instead of a subduction zone, what forms is a collision mountain belt. This process is responsible for the formation of vast mountain chains we know today. Probably one of the famous examples is the Himalayan mountain range, where Mount Everest is located. This mountain range was formed by the collision of Indian plate with the Eurasian plate. Reverse faults are likewise formed in this process and are responsible for localized earthquakes. Several phenomena are responsible for plate motion. The most popular of these mechanisms include mantle convection, slab pull, and ridge push. Mantle convection occurs because the asthenosphere is plastic. Therefore, it can flow, and because there is a difference in the density of materials in the interior of Earth. As the plates subduct, they become denser, pulling along the rest of the plate. Next, J. Tuzo Wilson was one of the first who formally applied plate tectonics to explain geologic records. Due to plate tectonics, there is a cyclic rifting in continents that formed ocean basins and subduction that resulted to the destruction of or closure of the older basins. This is called the Wilson cycle.
Because of plate tectonics, an oceanic basin may be actively changing size or may be relatively tectonically inactive depending on the movement of the associated tectonic plate. Elements of an active and growing ocean basin include an active and elevated mid-ocean ridge sloping towards flanking abyssal hills and plains, which sometimes terminate in an oceanic trench and subduction zone. Chronology of modern ocean basin development. Configuration and distribution of ocean basins have been changing together with the movement of plates in geologic time.